Let's have a look at a word problem and actually use some actual data from real life to see if we can model an actual real life situation. So let t be the number of months after 2011. From user data, we can find out that the monthly active users of Snapchat in month 7 was 5 million. In month 23, the number of monthly active users was 50 million. Use an exponential model to predict the number of monthly active Snapchat users in January of 2016, which is month 62. So here we're going to let Q equal the number of users in millions, and T be the number of months after November 2011. Okay, it says to use an exponential model, or any exponential model looks like Q of t is equal to Q naught, which is at this stage an unknown, e to the kt. K is also an unknown, and it depends on our on the data that we have. So this is an exponential model. This is kind of like our master equation, and what we're going to do is we're going to use the data that we have to figure out what Q naught and K are for our model. So from the first piece of data, when t is equal to 7, so when the months are 7, the number of users is 5 million, or in our case, we just write the number 5. So this allows us to write an equation. Equation 1 is 5, the number of users at time t, equals Q naught, which is something that we don't know, e to the k. And when was the number of users 5 million? Well, when t was equal to 7. So that's equation 1. Equation 2 is same kind of idea. In equation 2, we have that there was 50 million users precisely when t was equal to 23. Okay, so these are how we use the two pieces of information that we have about the users to build two equations out of an exponential model. So what we can actually do is use these two equations now to figure out what Q naught and K are for our model. So for example, if I take equation 2 and I divide it by equation 1, what I end up with is 50 divided by 5, so the left-hand side is just 10. The Q naughts cancel. Q naught divided by Q naught is just 1. And then I have e to the 23k divided by e to the 7k. And of course, when you divide similar bases, you subtract the exponent. So I have e to the 23k minus 7k, which of course is just e to the 16k. So now, because I'm trying to figure out what k is, and it's in an exponent, what I'm going to do is I'm going to take the log of both sides. So ln 10 is equal to the logarithm of e to the 16k. And because I know my logarithm rules, I know that if I have an exponent inside of a log, I can bring the exponent down front. So I have 16k times ln of just e, because the exponent has been taken down front. And this, of course, ln e is just equal to 1. So my equation becomes ln 10 is equal to 16k, which I can rearrange to have that k is equal to ln 10 over 16, which is approximately 0.144. So now that we have what k is, I can use k back in either one of these equations to solve for what Q naught is. So just for simplicity, I'm going to plug it into equation 1. So into equation 1. And what I get is, if I plug k in, I have 5 is equal to Q naught e to the 7 times 0.144, because that's what k is, we just solved for it, which means that Q naught is equal to, once I rearrange this for Q naught, 5 divided by e to the power of 7 times 0.144. And if I actually put that into a calculator, what I end up with is Q naught is equal to 1.83 approximately. I'll put an approximate sign here. Approximately. So now that I have Q naught and I have K for our specific data, I can build the exponential model to be Q at month T is equal to 1.83 e to the, and what is K in our case? 0.144 times t And now I can use this model to figure out what the number of Snapchat users at month 62 are. So if I use Q at month 62 is equal to 1.83 e to the 0.144 times 62, because now we're in the 62nd month. And if I just jump on a calculator now, I can figure out that, just put it in, e to the 0.144 times 62. I find that the answer is 13,798.5. So 13,798.5. Now we can ask ourselves, we can ask ourselves whether or not this seems like a reasonable answer. So remember that the number of users that we have here, it was 5 million. Here it was 50 million. Q is actually in terms of millions. So this would say that the number of Snapchat users in month 62, or January 2017, should change this as January 2017. Just change that right there. Is 13,798.5 million, which is 13.798 billion. So of course that's more than the number of people on the planet. So clearly something is a little bit wrong with our model. And what's wrong with our model is, of course, even though maybe for a little bit of time the number of users of Snapchat grows exponentially, of course eventually you start running out of users to add to the system. So the exponential growth starts to die off. So this exponential model might be good for the first handful of months, but it won't continue in an exponential fashion forever, and that's why we see this extra large number here.